Hello and welcome to a new video here on my channel here at commaik. For the past 12 months, I've been drying out the walls in this basement using the injection method. The areas above the barrier layer are drying well, and the indoor climate has also improved significantly. Unfortunately, the injection fluid has caused a negative side effect. Because of this, I am forced to install a sump pump in this basement. If you want to know what went wrong and how I'm building this sump pump, then stay tuned, it's about to start. A year ago, I started injecting a special fluid into my basement walls to dry out the masonry. To do this, I drilled holes in the wall and inserted bottles filled with the injection fluid. The fluid seeps into the walls and displaces the moisture. The walls become hydrophobic and waterproof. Since then, the moisture in the masonry has dropped from 1.6 to 0.8. You'll find my playlist for the basement drying project in the info box below the video. A few months ago, I tore up the basement floor because it needs to be rebuilt. This causes the area beneath the basement to dry out even faster. However, I've noticed a negative effect with my drying method. Some of the fluid has dripped through the holes and cracks in the wall and the intermediate ceiling all the way down to the basement floor. There, the injection fluid has spread out and made the floor waterproof in many places. The water that enters the basement from below during long periods of rain can no longer drain away or seep into the ground. Now the water evaporates in the basement or seeps into the surrounding walls. Both of these are very unfavorable for drying out my basement. So far, I haven't installed a sump pit or a soakaway shaft in this area. I was concerned that regularly pumping out the water might negatively alter the water pathways beneath the house. The exterior walls were dried out 5 years ago and a drainage system was installed. Here in this area, we are about 5 meters below ground level. The dimpled membrane on the outside and the drainage pipe are located about 3 meters underground. It couldn't be installed any deeper without compromising the house's foundation. The foundation consists of compacted sand and gravel. As a result, water can enter the building from below. I've now spoken with several experts and have decided to install a pump shaft or sump in this basement to automatically pump out the excess water. For this, I will use the following components. A 315mm kg pipe with a length of 1 meter. This pipe serves as a shaft and water collection point. At the same time, the pipe secures the surrounding area so that no soil can slide in. A self-switching submersible pump. I chose this model from Einhell. This pump has an integrated float switch. It therefore requires very little space. The pump has a power of 750 watts and a delivery rate of 15,000 liters per hour. For me, a sufficiently high delivery head was important. This pump can pump water up to 10 meters high. That should allow me to get the water out of the basement without any problems. The water is transported via a 1.25-inch garden hose. I will also need a few small parts. For example, this reducer with a 1.25-inch female thread to a 1.25-inch male thread. Combined with a garden hose coupling, I can connect the garden hose directly to the pump. I will now cut open the basement floor and install the kg pipe. To do this, I mark the position and first open up the basement floor. With my angle grinder, this is quick and easy. Once the hole is large enough, the kg pipe is installed. So that water can collect in the kg pipe, I will drill small holes in the side. For this, I use a metal drill bit. The pump is capable of pumping out dirt particles up to a size of 5 millimeters. So the holes should be smaller than that. Since the kg pipe is open at the bottom, I add coarse frost protection material there. This way, water can flow into the pump shaft without clogging the pump's opening. Alternatively, I could also place a metal mesh wastebasket at the opening. This would then work like a large sieve. The kg pipe is aligned with the spirit level and also filled with frost protection material from the outside. At the top, the pipe protrudes above the ground. Maybe I'll fill the basement floor with concrete later on. Then the pipe would be flush with the ground. Alternatively, I can also saw off the kg pipe. Now it's time for the pump to come into play. Before I lower it into the pipe, I install the reducer and the quick connector for the garden hose. Alternatively, I could also attach the hose directly to the pump outlet with a hose clamp. But my version is more flexible. I can take the pump out of the shaft at any time and remove the hose without any tools. This pump has an integrated float switch. It activates at a water level of about 12 centimeters. Manual continuous operation is also possible. For my purposes, however, I activate the automatic mode. As soon as the water in the pump shaft rises, the pump activates and transports the water outside through the garden hose. After the shaft is installed, I can lower the pump and do a test. Some water has already accumulated. Let's see if my pump shaft in the basement works. It works. The pump switches on automatically and pumps the water outside through the hose. The automatic shutoff also works perfectly. I hope that this measure will sustainably support the drying out of my basement. And if you want to support me or find out how my projects are progressing, then subscribe to my channel. Turn on the bell so you don't miss any of my new videos. Use my product links in the description below the video and give me feedback in the comments.